Welcome to Engineering Scale Models Presents. I'm Jason, your host. Well, I do models. Almost forgot that part. We are back in our Make Electronics 2nd edition by Charles Platt book. Here we're on Experiment 8, a relay oscillator. So let's get out the components we're going to need. Now I have one of these fantastic Pro Tech Trader Experiment 1 through 11 kits in here. See, it covers experiments 1 through 11. There's 3 packs of these. They're a little expensive, but it comes with everything you need, and you just get ready and go. So we're gonna need we're gonna need a breadboard for one. So I'm gonna get our breadboard. I'm gonna use this breadboard. It's not the breadboard that comes with it, but it's the one I'm gonna use. We need I'm going to plug in my own 9-volt power from a power supply, so I don't have to use a battery and battery connector. So I'm going to have my own 9-volt supply. This is just the same as having a 9-volt battery. There's no difference. I need 2 generic LEDs. The Tactile Switch. See, I like to get this stuff out, live with you guys. So we got a Tactile Switch over here. Okay, 470 ohm resistor. Ohm resistor. That is yellow, purple, brown. So, and this is nice. The kit labels them really nice, but you should always check your colors. I got my little color card here. Came with a box of resistors from E-Projects. Let me just show you this box of resistors because I have a few of these. I use these E-Project. They're 43 different value resistors. These are 1/4 watt, 5 tolerance, and they're the carbon film. So they have the 3 stripes. That's my favorite. I don't care if the tolerance is a little more. It's okay for what I do. It comes with 175 pieces, 25 of each value, and they're all in this box, and they're all labeled with a little sticker in numerical order. So it's just like a filing cabinet. You go through here and you pick your resistor and you grab what you want. I have that one, and then I have another one. This is different. This has 85 different values in it, but it only has 15 of each resistor, so it has like 1 ohm, 2.2 ohm. So it has some more of the larger range, all the way up to 10 meg ohms. So these are, and it has the color code inside the box. So these E-Project kits are nice. They even have one for capacitors. 36 value capacitor kit. It comes with ceramic disc, mylar film, and some electrolytic. So you have all your capacitors just all organized by value. So they're very nice. So anyways, I got my 470. Now I need a 1000 microfarad capacitor. Okay. I wonder if that's going to be an electrolytic capacitor. No, it's not this tantalum. Must be one of these electrolytics. Yep, right there. Electrolytic capacitor. Figured with a value that high it had to be electrolytic. Okay, so that's a big boy capacitor. That's a big boy. Alright, so we're going to... I have hookup wire. I'm going to use my breadboard wires for this. And then I'm going to get two LEDs. I'm going to get a red and a green just out of my LED drawer. Okay, so we got a beginner board here. So let's see. Let's look and let's copy what they have here. So they have this going. Well, it's got to go this way because positive's going over here. So they have. We'll start with this switch here. Let me zoom in a little bit on this. Okay, so here's what we're going to do. We're going to put this switch right here across the... Of course it won't fit across the power rails. So we're going to have to jumper it. Okay, these switches are not cooperating. Okay, so put the switch in there and we'll have to connect one end of it to power. The other end's going to go to that relay. So this end's going to go to our VCC power rail. VCC is your power rail. And then, oh, I didn't get out the relay. Oh, you're probably screaming at me. Get the relay out. I only have one good relay left. Because in the last one, I had to take one of these relays apart. Okay, so seriously, oh, now go back. It doesn't even tell you. Maybe that's just extra stuff you need. Oh well, we'll find out what we need. So the relay needs to be in the same line as the switch, going like that. And then we need a positive LED going from that pin there, and then positive to this second pin here. Alright, just wanted to make sure I lined that up correctly. Okay, so we have that there like that. Now I need to tie this to ground over here. Sometimes these wires can be a pain in the butt to go in. There we go. So that's negative here. That's this connection here. Then we need this 470 ohm resistor. And we need to put that between negative and this. We're going to jump that gap. We're going to jump this gap with a jumper here. Now I have yet to turn on my power supply, and there's a reason for that, and I'll go over that in a second. I'm not a fan of that board. Okay, so I have the jumper into the negative. Okay, so I'm going to turn on my power supply now. I'm going to get my power cable. Plug in. Now, while the power supply is warming up, and I am going to set it for 9 volts. So that's what it says to do. 9 volts. Alright. So, we have this set up. So let's just double check this. We have positive to one end of the switch. Oh, look, see, we missed the jumper. So this pin here needs to go to positive. This pin here is there. Okay, so let me make sure all that's connected up. Check. All those are lined up. I got the polarity right on these. Seems to be. I got my resistor in. Alright. So it seems to be all hooked up here. Let me plug into this power rail here. I have to plug it down here because of the way it's designed. Okay, so we're going to plug this in and hope for no explosion. And this is power rail 2. Okay, so we have the green light lit saying the relay is not open. And we close the relay, the red light lit. It's hard to hear the click of the relay. So kind of hear the clicking. So you see the light changes as we did the circuit on the breadboard. Okay. Let's check and see what we need next here. And talks about the breadboard. I can take this off now. We know what we're doing. Talks about the breadboard. Okay. Now it wants us to make this thing oscillate between two states. So let's reconfigure the board here. Let's take our power rail off. So there is nothing connected to the switch. Oh, the switch is now this way. Switch is now that way. Okay, and then I need a jumper from the switch to the same pin as this LED here. Oh, that's too big. So from this pin to that pin right there. So let's sure there's no other changes to the circuit to ground, but in that to that, LEDs are still hooked the same way, jumper across. Alright, let's see what this does. Got my power rail and doesn't like that at all. Why doesn't it like that? Let's turn the power off and find out what's going on here. So we have one end of the switch going into let's look at the schematic here. Oh, okay, it does make a buzzing sound. We got that. You're hearing that. Touch the relay to feel. I'm not going to touch the relay to feel it vibrate. I'm good. So hey guys, if you want to make a vibrator, you know, just there's the circuit layout. There's the schematic. Go to town. It's probably not going to be safe. So now we have the same circuit with the capacitor. So we have this capacitor, and we got to do some funky stuff with the legs of the capacitor. Now, capacitors, be very careful with it. If they're in a circuit, then don't touch them unless you know that they're discharged. Going to bend these down in a weird way here so I can get this plugged in. Okay, so it goes across this like If you guys have this much difficulty with your breadboards, let me know. And listen guys, I have better breadboards. This just happens to be a free-floating breadboard that's not tied up with a project. So I have a lot of test circuits going on, so this is what I have available. Okay, so let us double check the capacitor, make sure the negative's going to the negative. You can see the negative there because this sucker will blow up. So I'm going to connect my 12 volts to it. Make sure there's no other changes to the circuit. No other changes to the circuit. Nope. And we're going to see what happens. Okay, so you press the button and it doot. Okay, well that's interesting. That's interesting. We're just gonna... Now, here's the interesting part. I'm sure that capacitor is charged up. So I'm going to show you how to safely discharge a capacitor. Now, this isn't the be-all, end-all of discharging the capacitor. Is how I do it. I'm going to get a 1 meg ohm resistor. Actually, I'm going to get a 470K. We'll take a 470K resistor from my E-Projects bag. Take it off the spool here. Messed up my Xuron clippers. I'm so mad. Xuron clippers are expensive. Love them though. They're like my favorite kind of snips. Just my favorite tools for electronics in general is the Xuron. And I messed them up. I will show you how I messed them up. If you can see this. Let me see if I can get a shot on these clippers. See the hole? That's not that right there. See that? That's not debris. That's a notch I clipped out of my clippers that I can't fix. Followed them a little bit, got the burr off the notch, but yeah, I messed them up. I'm so sad. I love my Zeron, and you can see they're original Zeron. I thought they were built better than that, but I probably cut something I shouldn't have cut. Or someone cut the piano wire, or tried to cut piano wire with it when they were doing their own project. Okay, so I'm going to take this resistor here as I digress, and I'm going to bend it a little bit. And I am going to take it and stick it across that capacitor with a pair of pliers, not my fingers. And we'll let this sit for a bit. Okay, that should be discharged. Okay, so I'm still not going to touch it. So let's move on here. Let's see what's next in our little circuit. We'll keep our 1 mega ohm resistor for discharging. So it talks about how a capacitor works. It charges up and then it discharges. You have the two symbols, electrolytic and non-polarized, and polarized, which is normally your electrolytic. Some other capacitors have that. So it talks about don't burn up your boards, fault tracing. And the next thing is experiment 9, time and capacitors. We're going to learn about RC time constants, which is a pretty cool concept. So I'm going to enjoy this one because I use a lot of RC circuits in my projects. Like for example, right here, this setup with this capacitor and this capacitor and these resistors here, that's an RC circuit for a time delay to debounce a switch. There's time circuits, RCs on this 555 timer, this 555, and then this. Just there's one there, don't worry about it. It's just a mess. I'm not proud of that one. We'll get to that later. So that's going to do it for this video, guys. You can support me on social media. You can also support me on Patreon, and there'll be a GoFundMe in the link below. You can help me get some equipment. Let me show you what I'm trying to. I got all this stuff here from Singlet. That's a multimeter, a arbitrary waveform generator, a oscilloscope, and another meter, because I was 2 meters, and then a bench power supply, all from Singlet, on loan for me for 2 months. And I have a chance I can buy it. Well, that's really zoomed in there. And I have a chance that I can buy it after the 2 months at a slightly discounted rate. So if you guys want to help me out, you can go to my GoFundMe and donate money so I can purchase this equipment and get some other cool projects. And that's going to do it, guys. Thank you so much, and have a